Alright, so we are working on a 84 JLG boom lift controller, and the customer complaint is he's just saying that it's not functioning the way it should. You can hear something clicking on the machine, but the machine's not throttling up and not moving the machine. It's not swinging the boom from left to right. So I've been working on this machine for a little while now, and I have a good understanding of it, and I'm betting it's probably this switch here. This one is going to activate the hydraulic pump on the machine in order to get the whole machine to swing. So first, I'm going to just do a continuity check on this. I'm going to move the joystick and see if this actually has good contact. And I'm also going to go through the outputs of this in case you're wondering how this functions. I'll go through some of the other circuits, but first we're going to hook this up to the multimeter and test it out. So let's do that right now. Let me get you focused on the meter. Alright, so here I got you focused on the meter. I'm going to take a resistance measurement on the switch. Hopefully it's just close to 0 ohms. That's what it should be. This lift has had a lot of problems. Hopefully you can see that. So it's kind of, it should be open circuit, which is why you see everything floating around, but let's operate this switch here. Let's see if I can do this. So that's saying we got almost 500 ohms. It shouldn't be. The more I turn this lever, it still stays around 500 ohms. Let's go back the other direction. About 500. That should be around 0. There's no reason for that to be around 500 ohms. I'm actually going to operate it manually here by pushing on a little lever. I don't know if you're going to be able to see that. So right in here, there's this little lever is controlled by this little cam, and it pushes this down to activate the switch. Now we're at 5 ohms, which is still too high. And I'm gonna put this down and test it some more. Oh. I'm just gonna push on this just till it clicks. Alright, so it just clicks there. 800. I'm gonna keep pushing it. 600 and drops right down to what, 200 now. Seems the more I push on it, the lower it goes. 3 ohms. That's about as low as it goes. 3.3. I'm just releasing it a little bit. So it almost seems like it's supposed to have some varying control there, but it's not supposed to have a varying control. Now I have another one here. This goes to, it's basically the same thing. This goes to another function on the lift. So what I'm going to do, I'm going to connect it the same way. We'll operate this. And that's under 0 or almost 0 ohms. That's perfect. Let's go back the other way. Boom. So that's what it should be. It shouldn't be 800, 500, or anywhere in between. Or what do we get down? 4 ohms. So we're going to replace this switch. plastic riser. So this here, that's what the switch looks like. I actually got new ones. I got two of them. There's the old one, the new one. Side by side. I'll put the part number down in the description. Alright, I wanted to point out something here. This is something you might run into. You're supposed to hear a click. I don't know if you're going to be able to hear this. You should be able to hear that. When that clicks, that switch is on. It's closing. But when I operate this, there's no click. No click. So what I'm going to have to do is I'm probably going to have to bend this tab a little bit, just beyond out here somewhere, just so I can push down on this lever just a little bit more. There's a little button in here that it's going to have to push down on. Alright, so I got the switch on. If you look at that lever, you can probably see, get my hand out of the light, you can probably see a little bit of a bend in there. Not much, just enough though, so that now when I operate this, I'll get this closer. You can hear the clicking, and it clicks just before it gets up and over, but it is pushing it even more, so it is making a full contact. So now that that's out of the way, we're going to solder these wires back on. Alright, so let's hook this up. See if I can get these to stay on here. Clip just the wire there. Alright, let's give it a shot. Yep, just about 0 ohms, just exactly what we want. There's no variation. As soon as I move that lever, it's the same throughout the whole way. So that'll be fixing that issue. So now I'm going to hook this up to, I got a power supply. I'm going to hook this up to the power supply. I'm going to show you on the oscilloscope how exactly this whole thing works. Alright, I just wanted to show you specifics on the power feed for the pump, the average voltage of this pulse width modulated signal, and the duty cycle, just to further explain how this is functioning. So right now, I'm going to operate this joystick, and you can keep an eye on the current measurement of each, and that'll give you the real time. See, right now, just sitting here, it should be about 50%. I might need to make an adjustment on the potentiometer on that cam to get that closer to 50. So it looks like right now there's more ground than power, but that's okay. So that should be around 50%. Our current voltage is right around 5.5 volts, which is good. And this is just floating. There's no voltage right now on the blue line, on the blue trace. So let's activate this. See that pump activation circuit or the dump valve circuit turned on? And as I move this, you can see the pulse width shrinking. Our average voltage went down. Our duty cycle went down. Bring it right back up to center. Pump shuts off. Pump comes on again, going the other direction. Duty cycle is going up. The average voltage is going up. So that's how it should work. So now I'm going to put a video up on what this looks like with some incandescent light bulbs. You'll be able to see one light get brighter and one light get dim, and vice versa. So here's a diagram of the circuit board, and it's exactly the same as the one that we're just working on, except this came from a different controller. It just has 2 switches instead of 1. If you're diagnosing, if you had a problem on a lift, this particular lift, and maybe some other lifts use some similar controls. These are PQ controls. So, well, you have a thermal switch, which is an overload protection that protects the rest of the circuit. You have your switches here, which turn, the top one will turn on the hydraulic pump. And you have your potentiometer. These are your main culprits. Everything else, this circuit's pretty well protected. You shouldn't have any issues. You got transistors, MOSFETs, you got your controller here, you got resistors, capacitors. So here's your pulse width modulation output. This is what's going to be going to your controls. Down here, it's really big. Right here, this dark green line, that would be coming from this pulse width modulation output right here, pin D. That's coming from the center pin of your potentiometer. So if your solenoids, for some reason, are pulling too much current, you're getting worn out, or there's a short circuit somewhere, this thermal switch is going to start overheating, and it's going to start reducing the amount of current to the point where this circuit is not even going to be operating, or at least you're not going to have an output, or it's going to be very, very minimal. And your machine's, your function's probably not going to work. So if you have an issue where the function is not working at all, or slowly, not correctly. See if this is hot. If this is extremely hot, you should be able to touch it with your finger. If that's extremely hot, then you probably have an overload situation going on. The other option is maybe you have an issue with your potentiometer. Between this terminal and this terminal, you should have 50,000 ohms, 50k ohm between them. This is the wiper, your center terminal. You should have about 25 ohms between this terminal and this one, and between this one and that one. Now, on this particular one, it's 50k between them. On the one that we are just working on, even the part number comes up as a 50k ohm resistor, but the one we're working on, even though it comes up as a 50k ohm resistor, it measures out at 100k, which is a little odd, but it does function exactly as intended. So even though it measures at 100k, we have 50k between here and here, 50k between this pin and that pin, and you have pretty even voltage. So we have anyway, 11.5 volts or something like that between this pin and this pin when you sweep it one way, and then it drops to, I think, 0.3 volts when you swing the joystick the other direction. And you can check it. You can go between this pin and that pin and see if it's the same. You should see about, well, I was putting 12 volts to it on the bench, which brought this to about 5.5 volts between these two pins or between these two pins. Next is your switch. So the switch, very simple. You want to make sure that when you operate the joystick, this cam moves, pushes this lever in, which you kind of see a white, kind of a cloudy button there. That needs to get depressed into the switch. And then these two terminals need to close. They need to contact each other internally. So if you can get continuity between these two and you can get close to 0 ohms between the two switches with this operating, then you're good. If you have anything, if you have 5 ohms, 10 ohms, 500 ohms, 800 ohms, like we were getting with the other switch, then there's a problem and it needs to be replaced. With the, let me shrink this up. So this is your solenoids here. So you have one solenoid that's connected to power, one solenoid that's connected to ground. So with that pulse width modulation, when the pulse is high and the average voltage is high as well, say it's, you know, you're at full extension of that joystick and you're getting 11 volts. Well, if you got 11 volts on this wire, then this solenoid is operating. If you have 0.3 volts on that wire, you got more ground, bigger potential between these two lines here, because this has power and that has a higher voltage and has lower voltage, this solenoid will operate. This is where your joystick is. Up here, you got your blue line is your dump valve circuit or your hydraulic pump circuit. You got your just brown lines here are your ground. These orange lines are coming from the foot pedal. That's going to supply power to the joystick to power it up. That's also going to supply power down to the solenoid. And this is your pulse width modulation circuit. It's your control circuit. And now it's all going to come down here. Your pulse width modulation circuit, your control circuit's right here. And the power supply circuit from the joystick is right there. So you want to make sure you have voltage coming out pin A or terminal A to activate that hydraulic pump just down here on the circuit. You want to make sure you have a good ground, 100 millivolts or less. Well, it could be 300 millivolts or less, but you want to make sure it's low. You want to make sure you have good power coming in. Make sure you have good control going out. It's a very simple way circuit to test. Even though it's a spaghetti mess of wires in the machine, it's actually fairly simple to test. I'll leave you with that. And make sure to like and subscribe. This content helps you out. And we'll do something in the next video.